Welcome to Thermophysics Part 2. In this video, we're going to take a look at instruments that are used to measure temperature called thermometers. So a thermometer is basically an instrument that is used to measure temperature, as I said. They make use of a physical property which changes continuously with temperature to show the temperature. So their job, of course, is just to show you the temperature of a surrounding or of a given surrounding. So the way they do that is they use some different physical properties which change when temperature changes. One example of such a property can be thermal expansion. So you can get an object, then use the property of thermal expansion such that when the temperature changes, whatever object you are using is going to expand, and by the extent of expansion you should be able to tell the temperature. So there are different physical properties, but this which depends on thermal expansion is just one example. So here are some common thermometers and the physical property they make use of. We've got liquid in gas thermometer, which basically takes advantage of the volume of a fixed mass of a liquid, or the expansion of the volume of a fixed mass of a liquid. So there will be a fixed mass of a liquid in the measuring instrument. Then this fixed mass of a liquid, when it is exposed to a different temperature, it will expand or contract. Contract is to become smaller, the opposite of expansion. So depending on where you have put it, it will change in volume. So the volume of this fixed mass of a liquid will tell you the temperature. There is also what is called the thermocouple, which depends on electromotive force, which is more like voltage. So on a thermocouple, you are going to connect something that measures the electromotive force, and that electromotive force is going to be equivalent to the temperature of the surrounding. We're going to study these two in details. Then there's also what is called the resistance thermometer, which basically depends on the resistance of a piece of metal. Resistance is just the ability of a material to oppose the flow of electricity. So if a material says electricity can't pass through me, like most bad conductors such as wood, paper, they have a high resistance. So this resistance thermometer depends on this property. Then there's also called a constant, there's one called a constant volume gas thermometer, which depends on the pressure or the change in pressure of a fixed mass of a gas at constant volume. So it will have a fixed mass of a gas, so it can be 20 grams of a gas. At a constant volume, it can be 10 liters of the same gas. Then the change in temperature will result in the change in pressure. We're going to study how temperature is connected to pressure in the next video. So these are some of the physical properties and some of the thermometers that makes use of these physical properties. Now we're going to concentrate on liquid in gas thermometer. So this is how a liquid in gas thermometer looks. There are different types of liquids in gas thermometer, but this is a general one. So the parts are, we have this part here, which is called the bulb. Then inside the bulb, actually before I can go to what is inside the bulb, and we have a scale here, as you can see. So here there will be marks, maybe from 0 to 100 depending on the range. Then this part where the scale is called the stem. Then we also have this part here, which is called the safety chamber. Then this tube here, the entire tube, is called the capillary tube. But here, where this part of the capillary tube is called the bore, and this part of the capillary tube, this side, where I've said it's a bulb. Then inside the capillary tube, of course, that's where we're going to have the mercury or the alcohol, the liquid which we're discussing. So these are the various parts of a liquid in gas thermometer. So when you expose this to an environment that has a certain temperature, this liquid here is going to expand, and the level of expansion is going to be proportional to a certain temperature on this scale. So we're going to start just a special type of liquid in gas thermometer, but before we can do that, we're going to start like I've shown you, there are the types of liquids that are commonly used, mercury and alcohol. So we're going just to compare mercury and alcohol. We see which one should we choose and in what circumstances. The advantages of mercury, disadvantages of mercury, advantages of alcohol, and disadvantages of alcohol. So this is what we're going to study before we can go into a special type of liquid gas thermometer. With that being said, let's proceed. So these are some, not all, comparison between mercury and alcohol. The first is mercury is very poisonous. By the way, for those who are interested in chemistry, we know that this mercury is a liquid, but it's a metal. It's the only metal which is a liquid, a strange metal. But it is a liquid. It behaves like liquid. Everything is like that of liquids, but it's a metal, the only metal which is a liquid. That was just a side note information. Anyway, so mercury is very poisonous. So when you're using a liquid in gas thermometer that has mercury, if there's an accident, the thermometer breaks, you have to be very careful because that mercury can end up harming you. Well, alcohol is very safe. Anyway, I'm not sure about how safe it is, but if it can make you dizzy, then it shouldn't be safe. But anyway, it is safe according to this. Then also, mercury is very expensive, while alcohol is cheap. Mercury is silver colored and doesn't allow light through. So it is easy to see through mercury because of this silver colored and the fact that it does not allow light to penetrate through it. Well, alcohol is very colorless, which means that any expansion it will be difficult to see because it doesn't have a color. So what we do is we add what are called coloring agents. So we can add a red coloring agent so that we're able to see. Then there's also the issue with expansion. Mercury expands uniformly. That's the first point. So I want to go to this point. I want first to explain more on mercury expands uniformly. So what this means is a small change in temperature will proportionate to a small change in the volume of mercury. Just like that, any change is going to be corresponding to a small change in the volume of mercury. So a small change in temperature results in a small expansion, and you'll be able to see that. Well, alcohol, it doesn't expand uniformly. What that means is sometimes you can have a change in temperature, but you won't see any change in the volume of alcohol. Then at some point when the change is that much, then you're going to see that's when you're going to see a change in the volume of alcohol. So that's not very good because sometimes you might need a certain temperature which alcohol cannot show because of its ununiform expansion. Well, mercury is going to be able to give you any temperature that you want. Then the other side of this is mercury that does not expand very large. So even if there is a small change in the temperature, the corresponding change in the volume of mercury is going to be very small. So you need to be very cautious in reading this change. On the other hand, alcohol expands more. It actually expands 6 times more than mercury. So any change, as long as it is able to expand, that temperature change is able to expand alcohol, then you're going to see a very big change. So there are very big changes with alcohol because of its high expansion rate. So these are some of the advantages, disadvantages, comparison, and how we circumvent some of the disadvantages. For example, alcohol is carries with a coloring agent. There are more in the notes. I did more, but here I thought of just discussing these few. So this is a liquid in gas thermometer that has alcohol. So the coloring agent that was used here was a red agent, a red color, which that's the reason why we can see the reading here. Then this is an example of a liquid in gas thermometer that has mercury. With that being said, we want to take a look at a very good example of a liquid in glass thermometer called a clinical thermometer. I think most of us are familiar with this, those who have been to clinics. Maybe those who are not fans of going to clinic, maybe they haven't seen this. Yeah, those who like herbs, but yeah, for those who are constantly or just normally have been to a health center, you at some point, maybe when you had the fever, you maybe you had this in your armpits or your mouth. So let's go. Let's proceed. We discuss this special type of liquid in glass thermometer. So what is a clinical thermometer? This is just a thermometer which is used to measure the temperature of the human body. So by design, it was designed to measure the temperature of the human body. Therefore, you're going to find that it doesn't have certain readings like 100 degrees Celsius, because a human body cannot have a temperature of 100 degrees Celsius unless that body is dead in a fire or something. So this is how it looks. As you can see, this is the temperature range. The normal temperature of a normal person might be somewhere here. If it goes here this side, maybe you have COVID or something. Yes, but it means you are sick, and it shouldn't be low again. So this is how it is. So the most important feature that we did not highlight is this called the constriction. I'll explain its importance. So what makes this thermometer so special? It has certain features, and we're going to take a look at features and what gives it those features. The first feature, is it a feature, or anyway, the first attribute that it has is it is very sensitive, high sensitivity. So what makes it very sensitive? First, by the way, when a thermometer is being used, this part, the bulb, is the one that they put on the surface that has to be measured. Then the reading is going to be seen from this other side. So as you can see, the bulb is very big. So this large bulb allows it to be exposed to more parts of the environment or the object being measured. Therefore, it is able to detect more temperature, making it very sensitive. Also, it has a narrow bore. So this bore here, it's very narrow. So any small expansion will show some change, because it's very narrow, and any small expansion of this mercury is going to result in a movement, in an observable movement. Imagine if it was big like this, then a small change might not be seen because the mercury doesn't expand that much, and therefore a small change in the temperature, let's say a small increment in the temperature, will result in a small expansion. But since this bore is very big, so part of the mercury might try maybe to go up to cover the other parts of the bore, but it's very narrow, so a small change in temperature which will result in a small expansion, and the expansion is going to be noticed. So sensitivity can be seen as the can be looked at as the ability to respond to changes in the environment, which it does. Then another thing, by design, it has a short range. As you can see, the range here, it's very short. So the range is from 35 degrees to 42 degrees or 43 degrees. And this gives it greater accuracy. So accuracy is just not having errors. That's how I can put it for now. So mean that because of this short range, it will be able to show any change accurately, any change in the temperature accurately, because if the range was high, there can be mistakes at times. But what you can just get here, because I know the concept of accuracy in science is not an easy concept, so what you have to get is, because of this short range, it is very accurate. It gives accurate readings. Then also it has this property, it can record the maximum temperature because of the constriction, which prevents the contracted mercury from falling back into the bulb. So remember the constriction that I had said. So let me just bring the picture so that you understand this well. But maybe before I do that, yeah, I need to show another property, which is quick responsiveness. So it has a quick responsiveness Why? Because it has a thin glass wall of the bulb. So the glass wall on the bulb is very thin. So any temperature change is going to pass or to penetrate the glass wall, and it will be detected by the mercury, and the mercury is going to expand. So that's what it means to have a quick responsiveness. So now we go back to the constriction. So here, why is this not straight? Why is it bending here? What's the purpose of this constriction? So imagine you take a reading on a surface. So your mercury expands. It's somewhere maybe 37, or here where it is. Then you remove the bulb from the surface. Let's say the human armpit. So now you want to read. Okay, so the armpit maybe was warmer than the room temperature. So what's going to happen is the room temperature, the mercury is going to sense the change in the temperature and to start contracting, to becoming smaller, meaning that it will be going back. So if there was no this constriction here, if it was straight, it could go back. Therefore, by the time you're taking the reading, it won't be here, it will be somewhere here because it has gone back here. So because of that, you're going to take a lower reading instead of the maximum reading that you had measured on the object, or in the human armpit, so to put it. Yes. So that's why this constriction, the bending, allows it to record the maximum temperature of the environment or object it is measuring. We are going to take a look at temperature scales. So temperature scales, let's say you are given a project to make your own thermometer. How can you create a temperature scale? So this is a very important skill to create a temperature scale. It can come as a practical, but the steps are very simple. So first, let's get grounded with some of the terminologies that are used. So there are 2 points that you need to come up with, which are called fixed points. These are 0 degrees and 100 degrees Celsius. So 0 degrees is called the ice point, or the lower fixed point. So the lower fixed point of the ice point is the temperature of pure melting ice, which is 0 degrees Celsius. So you need ice which is melting, then you measure that temperature, and wherever your mercury thread is going to be, you mark that point as your 0 degrees Celsius. Then there's also what is called the upper fixed point, which is also called the steam point, which is 100 degrees Celsius, and is defined as the temperature of steam from water boiling under standard atmospheric pressure. It is 100 degrees Celsius. So you get water boiling, then put your thermometer there, where your mercury thread is going to be, you mark it as 100 degrees Celsius. Now here is the procedure. I've said most of it, but here is a step-by-step procedure. This question usually comes in as an essay type of question, where they ask you to describe how to make the temperature scale. So first, you place the bulb in melting ice. You measure the length of the mercury thread and mark the lower fixed point. 3. You place the bulb in the steam from boiling water. You measure the length of mercury thread and mark the upper fixed point. So you have the lower fixed point and the upper fixed point. The lower fixed point is 0 degrees, the upper fixed point is 100 degrees Celsius. Since the difference between 0 and 100 is 100, you need 100 marks in between. So you have to divide the interval between 2 fixed points into 100 equal parts. Then you have created your own temperature scale. Congrats. Finally, we take a look at what is called a thermocouple, which is another type of thermometer. So a thermocouple is made from wires of 2 different materials, e.g. copper and iron, welded or joined together. So these wires are welded or joined together, then they are placed in 2 different temperatures. Then there is a natural observation, which when you do this, you're going to have electricity in those wires. So this is a thermocouple. So I've got ice here. So we've got these 2 wires made of different materials, in this case of copper and iron. then we've got ice here and we've got fire here. So these wires have been placed in this, and because of these huge temperature differences, electricity is going to flow. That's something that was just discovered in nature. So the temperature difference is going to correspond to the amount of current that's flowing. So you can create a meter here which is going to map the amount of current to the temperature. So this is how a thermocouple works. So a thermocouple is very important to be discussed because it brings in two new features. One, it is very sensitive. So any small change in temperature corresponds to a change in the readings, and it can measure high temperatures because of high melting points of metals. So these metals, they can't easily melt. So you can even measure the temperature of the fire, the temperature of anything, which you can't use a gas thermometer, a liquid in gas thermometer. You can't put a liquid in gas thermometer to measure the temperature of the fire. So in such cases, industrial cases, you use a thermocouple because these ones have high melting and boiling points. So this marks the end of this part of physics. Hope you have enjoyed. Happy solving.